I'm Eric Decker with BizTimes, and this is Made in Milwaukee.
Since 1913, Maynard Steel has been making large steel castings for the mining, transportation, energy exploration, and military contracting industries. Some of these castings can be as large as 70 tons, and the company routinely makes gears for mining shovels and draglines that are 10 to 12 feet in diameter. The casting process starts with mold making, where workers pack special sand around metal forms that create the molds. Molten steel is then poured into the molds to create parts. Maynard Steel does its melting at night to take advantage of lower electricity rates. Even still, the company pays more than $1 million in natural gas and electricity bills every year. When the steel reaches the right temperature, large steel ladles are moved into place to collect the molten steel, which is later poured into the molds. At the top of the screen, you can see 3 electrodes which are in direct contact with the metal. These electrodes are made from graphite, and they're able to transfer massive electrical currents to the steel, which can raise it to more than 1,800 degrees. After the steel reaches the right temperature, it's poured into the waiting ladle. After the steel is poured into the ladle, workers take samples to make sure the steel has the right chemical composition. Samples are sent to a nearby lab, which quickly cool them, cut them into pieces, and use a spectrometer to analyze the chemistry. After samples are taken, carbon is added to the molten steel, which helps to minimize slag formation. While samples are being analyzed, workers take temperature readings to make sure the steel is within the required temperature range. After testing is done and Maynard's employees are sure the steel has the right chemical composition and temperature, it's time to pour. With guidance from the workers on the floor, overhead cranes move the ladle into position above the molds, and workers open the spout, pouring the hot molten steel inside. These molds need to cool for 3 days before they were opened, but some larger pieces need to cool as long as 2 weeks. After the molds have finished cooling, they're raised into the air with an overhead crane that drops them onto this ram that breaks them open. After the pieces are taken out of the molds, steel castings are shot blasted to remove excess material. Grinding follows the shot blasting process, and then pieces are put into heat treating where they sit for 12 hours to up to 3 days before they're ready to go out the door. This piece is ready to be loaded onto a flatbed and shipped to its customer.